Welcome back to the next session, that is breakpoint chlorination. In the last classes we discussed the pre-chlorination, post-chlorination, then double chlorination, etc. Is it? So, and the purpose of each type of chlorination. So now coming to the breakpoint chlorination. The breakpoint chlorination, it is actually for the identifying the application point or to practically when the chlorine dose applied is sufficient or when it gives you the residual chlorine, that is to identify that point of application. Here it is written, this term has come into practical use to refer the amount of chlorine required to treat the water. If water is pure and if it has no chlorine demand, any chlorine that is added to such water will come out as residual chlorine. This is shown by line P in the following figure, is it? So here in this figure you can see that the x-axis, it is applied chlorine in ppm, that is the chlorine dose in ppm, and y-axis it is the residual chlorine in ppm. So the first case, that means your water is very pure, and when we add chlorine, if your water is pure, there is no chlorine demand, is it? There is no chlorine demand, or chlorine demand is 0. So in that case what will happen? Whatever chlorine it is added, it will come out as residual chlorine, is it? That means chlorine dose minus chlorine demand is the residual chlorine. So here chlorine demand is 0. So that means the chlorine dose is equal to chlorine residual chlorine, is it? That is the free chlorine. That is shown by line P. So we are applying chlorine at different dose, and it is coming out as the residual chlorine. It is coming out as the residual chlorine. Now here you can see that at point A, from this point the curve, it is, even though the residual chlorine is increasing at this particular point, even though it is increasing at this particular point A, it is the curve has come down. That means up to point A, the residual chlorine is increased, but from this point, that means this curve, from this point, say it is x to A, the residual chlorine is not the same as the chlorine dose, is it? It is little bit of reduced. That means there is certain chlorine demand. And at point A, there you can see that there is a sudden decrease in the residual chlorine, even though the chlorine dose, that means the applied chlorine is increased, there is a sudden decrease in residual chlorine, and the curve AB, that is the curve Q, it shows a sudden decrease. And then from point B, the residual chlorine is again increased, so it is again increasing, and it is linearly increasing from point B, is it? So then what is point A and point B? So point A mean point up to point A, that means from the initial line P, the line PA, this curve, PA curve, that is, it shows the initial function of the chlorine demand. What is the first function? That we know it is the inactivation, or it is reacting with the bacteria. It is reacting with the bacteria, and as it is being used for inactivating the bacteria, the residual chlorine is getting reduced. The residual chlorine is getting reduced, but as we increase the, it is, since we are increasing the dose, it corresponding increase is there in this particular residual chlorine also, is it? So then from point A, point B, it is suddenly decreasing. That means at the same, again remember the chlorine dose we are gradually increasing, but there is a sudden decrease from point A to B at this particular dose. At this particular dose,